Hello, these would be the solutions for page 133, the odd numbers up through 19. Number 3, we want to find the measures of the angles of an isosceles triangle if the measure of the vertex angle is 40 degrees less than is a key word there, the sum of the measures of the base angles. An isosceles triangle would look like this. If these two angles are congruent, then the base angles are here and the vertex angle would be up here. So we would say let V equal vertex angle, and we'll say let B equal 1 base angle, and these are both in degrees. Now the first thing is that they tell us that the vertex angle is, the word is means equals, so V equals 40 less than. Now less than does mean subtract, but it also means subtract in the reverse order, so we're going to subtract 40 from something. What are we going to subtract it from? The sum of the base angles. Well, the base angles are B, so B plus B will give us 2B, and I want to take 40 less than that. So there's my first equation. To get another equation, you have to have some prior knowledge about triangles, and that is that triangle sums, or the sums of the angles of a triangle, add up to 180. So I have a V plus 2B has to equal 180 degrees, so all three angles have to add up to 180. Now I'm going to go ahead and use substitution on this since V is already by itself, so I'm going to take all of this and put it right there. So 2B minus 40 plus the 2B, which was in the original problem, is equal to 180. Combine our like terms, so we have 4B minus 40 equals 180. Add 40 to both sides, and we end up with 4B is equal to 220. Divide both sides by 4, and B ends up equaling 55 degrees. Now B is a base angle, so there's one angle at 55, but I actually have two of them, so if I times that by 2, that gives me 110. And if I subtract that from 180, that will give me my vertex angle, so 180 minus 110, my vertex angle will give me 70 degrees. So I have 55 degrees for the two base angles and 70 degrees for the vertex angle. Number 5, on Friday, With It Clothiers sold some jeans at $25 a pair and some shirts at $18 each. So they're telling me some information about jeans and shirts. If I look at the question, how many pairs of jeans and shirts were sold each day? So I will use let J equal number of jeans sold. And I'm not going to use a S, I'm going to use the second letter here, which is an H, to represent number of shirts sold. And then we'll go ahead and read the rest of the problem and put together our equation. Now they did tell us that they sell jeans at $25 a pair and shirts at $18 a pair, and for that day they totaled 441. So $25 times the number of jeans you sold plus $18 times the number of shirts you sold is going to equal $441. And then they said on Saturday the store priced both the items at $20, which means the jeans and the shirts are both $20. But they only had receipts of $420. So they have a $20 times the number of jeans plus $20 times the number of shirts equals $420. And there's our two equations. Now you just got to decide what do you want to do, substitution or elimination. Normally I like to use elimination or combination, but I am going to use substitution in this case. I'm going to isolate, let's say, I'm going to isolate H. So I'm going to rewrite this equation. So it's going to be 20H is going to equal 420 minus 20J. Then I'm divide both sides by 20, and H will end up equaling 21 minus J. Now I can go to the other equation and take this H out and put what that H is equal to. So I have 25 times J plus 18 times 21 minus J, and that whole thing is going to equal 441. Continue solving for J, distribute, so 25J plus 18 times 21 is 378 minus 18J is equal to 441. Now I am going to combine these J's together and move my 378 over to the other side. I'm going to do that first. So my 441 minus the 378 coming over will give us a total of 63. And 25J minus 18J leaves us with 7J. Divide both sides by 7, and the number of jeans equals 9. Now if I want to solve for the number of shirts, I have to take this 9 and then replace it or substitute it either here or here. I'm going to do it on the bottom one, and that's going to give me 180 plus 20H equals $420. Subtract 180 from each side, and we get 20H equals 240, and then divide by 20 on both sides, and H equals. So we would have had 9 pairs of jeans and 12 shirts sold each day. Number 7, with a tailwind, a helicopter traveled 300 miles in 1 hour 40 minutes. The return trip against the same wind took 20 minutes longer. So that's a headwind, but they're still going 300 miles. Find the wind speed and also the airspeed. So we're looking for the wind speed and the airspeed, so let W equal wind speed. Let A equal airspeed of the plane. Now this is really a rate times time equals distance calculation. Well, conveniently the distance in both directions is the same. So I have 300 miles equaling the rate and time of 2 different trips going the same distance. Now what you want to do is convert this to all hours, and of course this is 20 minutes longer than the other one. So 1 hour and 40 minutes is really 1 2/3 hours, so 1 2/3 hours, but it's best to use an improper fraction here, so we're going to just call that 5/3. So the rate is, or the time is 5/3 hours. So 5/3 hours times, now we got to figure out the speed. The speed is the helicopter and going with a tailwind. That means the wind is pushing it. That's going to increase the speed by whatever the speed of the wind is. So I'm taking 5/3 of A plus W. So A plus W gives me total speed with the wind. The return trip took 20 minutes longer, so 1 hour 40 minutes plus 20 minutes more gives you an even 2 hours. So that rate, or that time, is 2 hours. However, it was a headwind, which means airspeed of the helicopter is going to be reduced by the wind speed for the total speed on the return trip. So it would be A minus W. Now I'm going to go ahead and simplify, not by distributing, but getting rid of the 5/3 and the 2 on both sides. So I'm going to divide this one by 2, divide this one by 2. But up here I'm going to multiply by the reciprocal, which is 3/5, and multiply the reciprocal here, which is 3/5. So the 3/5 and the 5/3 will cancel out, leaving A plus W equal to 3/5 of 300, which is 180. And the 2's will cancel out in the second one, leaving me with A minus W. And 300 over 2, or divided by 2, is 150. And these are setting themselves up for using the linear combination or elimination method. What I'm going to do is add these together, and what will happen is the W's will cancel out because they have opposite signs. So 180 plus 350 equals 330 miles. And then that is going to equal A plus A, which is 2A. And of course, A plus, and of course, W plus negative W is just going to be 0. So divide both sides by 2, and A equals 165. So that's 165. I think that's miles per hour. So in order to figure out the wind speed, we'll take that 165 and substitute it back into one of our problems. I'm going to substitute it right here because this one is easier to work with. Again, 300 divided by 2 will still give me 150, but in place of A I have 165 minus W, so I'm going to subtract 165 from both sides. I'll end up with a negative 15 equals a negative W. And then to get the W back to positive, multiply both sides by -1, and that will give me a W equal to 15 miles an hour. So the airspeed of the helicopter is 165, while the wind speed is only 15. Number 9, an overseas phone call is charged at one rate, which is a fixed amount for the first minute, and a different rate for each additional minute. If a 7-minute call costs $10 and a 4-minute call costs $6.40, find each rate. Okay, we got two types of rate. We've got the first minute rate. So let F equal dollars for first minute. And then we've got the variable or additional rate. I'm going to go ahead and use an A there. Additional rate would be dollars for each additional minute. So a $10 cost comes from the first minute times 1 plus, now it was a 7-minute call, but the first minute is already taken care of, so we only have 6 additional minutes, so it would be 6 times A. So the total $10 is F plus 6 times A, and the second call is $6.40, and we still have the first minute, but it was a 4-minute call, so we have 3 additional minutes at the same rate of A. And there's our two equations. Now, since these are already set up with the F's lined up and they have a coefficient of 1, I recommend using the combination method and just subtract. So $10 minus $6.40 leaves you with $3.60 equal to, now the F's are going to cancel out, and that will leave us with 6A minus 3A, which is 3A. Divide both sides by 3, and A equals $1.20. So each additional minute will cost $1.20. Now if we substitute that back in for A, let's say I put it right here. I have 640 is equal to F plus 3 times $1.20. And 3 times $1.20 is going to give us $3.60. 640 equals F plus 360. Now all I gotta do is subtract 360 from both sides, so the first minute cost comes out to $2.80. Now it comes out to 2.8, but money has 2 decimal values, so the first minute is $2.80. Number 11, a financial planner wants to invest $8,000 in some stocks that earn 15% annually and the rest in bonds earning 6% annually. How much should be invested at each rate to get a return of $930 annually from the 2 investments? So how much should we invest? That's how many dollars. So let's start off with let A equal dollars at 15%. So that's how much money we're going to put in at 15%. And B is going to be dollars at the 6%. So it's really stocks and bonds, but I'm not going to use the S because S looks like a 5. Now these are actual dollar amounts. So A is dollars, B is dollars, and I know I have a total of 8,000, of which I'm going to invest all of it. Therefore, my first equation is A plus B is going to equal $8,000. Now the second equation is a little bit more difficult to calculate. This right here is dollars also, but it represents interest or return, and that's calculated using the percentages of 6 and 15. So that $930 is going to come from A, which is 15%, which is 0.15 at A, plus 0.06 of B. So in the second equation here, you can see that it actually has some decimals in it, and I do like to use the combination, but I don't like to do it with decimals. So all I'm going to do is multiply this entire equation by 100. That will clear my decimals out. So I will have 93000 equals 15A plus 6B. So all I did was distribute that 100 to all 3 of these terms. Now the reason I do that is because I want to use linear combinations. So what I'm going to do over here is multiply this one by some number to eliminate either A or B. Now B is the smaller value. B has a 6 here. So I'm going to times this whole equation by 6. So I end up with 6A plus 6B equals 48,000. Now since the A's and the B's are not lined up, I'm going to rewrite them so that I have 6A plus 6B and 48,000. 5,000 on this side, and what I just did there was use the symmetry property just to turn that whole equation around. And the reason I did that is so that my A's and my B's will line up so I can use combination. Now my B's are both positive 6's, so to get them to cancel, I'm going to subtract. So 93,000 minus 48,000 leaves us with 45,000 equal to 15A minus 6A is going to leave us with 9A. They're going to divide both sides by 9. And A, which is the 15%, is going to give us an investment of $5,000. So we're going to invest $5,000 at 15%. And then if I put $5,000 right here in place of A and then subtract it from $8,000, my B value, which is my 6% account, leaves me with only $3,000. Number 13, Marcia flew her ultralight plane to a nearby town against a headwind, that means into the wind, of 15 kilometers per hour in 2 hours and 20 minutes. This right here, I'm just going to call that 2 1/3 hours, 2 1/3, which I'm going to then rewrite as 7/3 hours. I like everything in hours. And the return trip under the same wind conditions took 1 hour and 24 minutes. Well, that's 1 hour 24/60ths, which I believe is 2/5. So that's 1 2/5 hour. I'm going to call that 5 times 1 plus 2 is 7/5 hours. So I've got 7/5 hours and 7/3 hours. Find the plane's airspeed and distance to the nearby town. So that's pretty easy. Let's do let A equal airspeed, D equals distance to town. Now she's going to the town and back. So this is a rate times time. Rate times time equals distance. So the rate is, with this headwind, that was the headwind. The headwind means it's pushing against you. Well, we don't know what the plane is going, how fast it's going. It's going A. But we do know that the wind is pushing against it at 15, so that's going to slow it down by 15. That's the rate, and the time it's flying is 7/3 hours, and that's going to equal some distance. And on the return trip, it was a tailwind, meaning it's pushing the plane, so it's going to be A again, but it's going to be an increase of 15 kilometers per hour. But that trip took 7/5 hours. Took less time, but the distance was still the same. Now, one of the things we might notice here is both the D's have been isolated. So what that means is I can get rid of this D and put this in its place, and now I have a large equation in which I have variables on both sides. So my new equation would be 7/3 A minus 15 is going to equal 7/5 of A plus 15. Now, I don't like to have the fractions in there, so what I'm going to do is clear the fractions. So I'm going to multiply the entire equation, both sides, by the least common multiple of 3 and 5, which is 15. So both sides get multiplied by 15. So 15 divided by 3 is 5. 5 times 7 is 35, and I still have an A minus 15. Remember, this is all one term, and you only multiply it once. And then the 15 divided by the 5 here will give us 3, and 3 times 7 will give us 21, and I still have times A plus 15. Now I have to distribute 35A minus 525 equals 21A plus 315. All right, now combine my A's all to one side, which means the smaller A's are going to go this way, and my 525 is going to go this way. So on the other side, it's going to, the left-hand side, it's going to be 35 minus 21, which is going to leave us with 14A. On the right-hand side, it's going to be 315 plus the 525 coming over for a total of 840. Divide both sides by 14, and we get an airspeed of 60. And that was in kilometers per hour. Kilometers per hour. Now, if I want to go ahead and solve for the distance, go back to one of my original problems. Let's say I use, let's use this one right here. So 7/5 times 60 kilometers per hour plus 15 is going to equal total distance. Well, since the 60 and the 15 inside are both compatible with the 5, I'm just going to go ahead and distribute it. And 60 divided by 5 is 12. 12 times 7 is 84. And then distribute here, and 15 divided by 5 is 3, and 3 times 7 is 21. Add those together, and we get a total distance of 105. Now, this is in kilometers per hour, therefore the distance is in kilometers. Number 15, if a particle starting with initial speed of v sub o, that means its starting speed, speed 0, has a constant acceleration of a, then its speed after t seconds is given by the equation. V must be the speed at any given time by taking the starting speed and adding the acceleration over time. They want us to find the v sub 0 actually, which is the starting speed or initial speed, and a, which is the acceleration. If v equals 28 meters per second when t is 4, and v equals 43 meters per second when t is 7. Well, they've already given us the equation. We're just going to write the formula, which is right here. We're going to write it twice. So in place of v, we're going to have 28 equals, and we have v sub o plus, and I don't need that v sub o, so I'm just going to call it v, plus a times t, and t is 4 seconds, so it would be 4a. And the other equation is going to be 43 meters per second with initial velocity of v plus 7 seconds times a, 7 seconds times a. And these are already set up for linear combination, so I'm going to use subtraction here. So I have 28 minus 43, and we end up with a negative 15 equals, the v's drop out, and 4a minus 7a leaves you with a negative 3a. So divide both sides by a negative 3, and a equals 5. Now a is the acceleration, so a is 5 meters per second. So now we got to figure out what the initial velocity is. So take that 5 and put it back into, let's say, this equation here. So 28 is going to equal initial velocity plus 4 times 5. And 4 times 5 is 20. So when I move the 20 this side, my initial velocity will be 28 minus 20, which is 8 meters per second. And there's my solution. Davis Rent-A-Car charges a fixed amount per weekly rental plus a charge for each mile driven. A 1-week trip is 520 miles and it costs $250, and a 2-week trip of 800 miles costs $440. Find the weekly charge and the charge for each mile driven. So let W equal weekly dollars, and let M equal dollars per mile driven. Okay, a 1 week, which is 1W, plus my 520 miles times my charge per mile should equal 250, and a 2 week, 2W, plus 800 miles times my mileage charge equals 440. And I would use linear combination. I would multiply this side by 2. So I'm going to go right underneath here. So I have 2W plus 1040M equals 500. In order to get your W's to cancel out here, we're going to subtract. So 800 minus 1040 leaves us with a negative 240. And that's going to give us, this should be an M right there, 440 minus 500, and that's going to leave us with a negative 60. Divide both sides, and I forgot my M again. Divide both sides by negative 240, and M equals 0.25. So basically that's 25 cents per mile. So in order to figure out my weekly charge, I take my 25 cents per mile and substitute it in, let's say, right here. So I have 1 week plus 520 times 25 cents per mile equals 250. 520 times a quarter is going to give us $130. So we have $130 for mileage. Subtract 130 from both sides, and we have $120 for the weekly charge and a quarter per mile driven. Number 19, they give us an equation for the supply of a commodity at a certain price per price in dollars, and a demand for that commodity at the same price. Now they do ask us to graph this, and I do not want you to graph this. I'd rather use one of those other two methods. They do want us to find the equilibrium price, and that's where the supply is equal to the demand. So basically, this equation equals this equation. So go ahead and solve for P by writing 0.3 P plus 3 is going to equal negative 0.5 P plus 9. Okay, we're going to move the negative or the smaller coefficient over this way, and then we'll move the constant that way. So 0.3 plus 0.5 is 0.8 P, and that's going to equal 9 minus the 3 coming over, which is 6. Divide both sides by 0.8, and we get a price of $7. It says 7.5, but that's $7.50. What that means is if I have a price right here and right here of $7.50, the supply number and the demand number will be the same value. Now you do ask this question here, so we do have to have an idea of what the graph looks like. What will happen if the price is greater than this? So if the price is bigger than $7.50, we'll draw a little graph right here. The equation up top has a positive slope and a positive y-intercept. So it's going to be going upwards like this. So we'll call this the price, and the supply and demand will be on this scale. And this one down here has a positive intercept, which is a little bit higher, but a negative slope, so it's coming down like this. So where these two lines cross, that's our equilibrium. That's our price of $7.50 and our demand of 5.25 times 1,000. So as the price, which is the blue line, as the price gets bigger, the demand that follows it is going to get lower.